question number 7, when we get back, there's this fictional town. In this town, the city grid, it has blocks, but the blocks don't run north, south, east, west. They run at these funny angles. So north is up, east is this way, and the blocks of the city, they run sort of at these weird diagonal lines. There's details about which way they go in the question. And this question is about converting from north and east to city blocks. So if you've lived in a city like this, you're probably really familiar with this. It's important for this question that you have really the question in front of you. So I know for a lot of questions you can look at the screen and sort of get enough out of it. But for this one, I think it helps a lot to have really this picture in front of you. So make sure you have that. The first question is about converting. I'll open up that TopHat question and I'll give you guys a good chunk of time to work on that. Okay, let's see what you guys think here. The first part of the question is saying, convert the location, which is given in street coordinates as 2, 1, convert that into north, south, east, west coordinates. So like if you live in Manhattan, this would be saying, I'm going up 2 blocks and east 2 blocks. In Manhattan, up and down mean north and south. So you say, I'm going, well, I guess it's backwards. Okay, you're going east 2 blocks and up 1 block, east 2 blocks, north 1 block. And we have to convert this 2, 1, over 2 and up 1 into east and west. Let's see what you guys think. Do we have a consensus on the answer here? 2 east, 1 north. So we're going over two blocks to the left and 1 block up on the street grid. And we know the blocks are not aligned with north and south and east and west. And so it can't possibly be the same 2, 1 and 2, 1. It's going to be something else. We got some people at 5/2, 5/3. So I would say it's quite clear there is not a consensus on what's right hand. So a lot of people said 1, 2. So I think the people who said 1, 2 are not understanding what the question is asking. Yeah, so let me open this up again, and let me give you guys a hint. I want you to do it without using any equations. And in fact, you can do it just by staring at this picture. So just imagine you're a tourist to this imaginary city, and someone says, I want to go over 2 blocks and up 1 block. Where do you end up? And I think you can do it there. Okay, so let's see if there's a consensus now. Let's look at the word cloud. 1, 2 is in big answers. So some people were saying 2, 1. 2, 1 is what we were given. 2 over and 1 up. But if you look at the map, so if you just look at this picture and you treat it as a picture, the location 2, 1 is this point right here. So let me use the. Someone took my stick. Okay. Don't worry, guys. I found it over here. 2, 1 is this location, and you can get to that location by going 2 blocks over and 1 block up, or using the dotted lines, which are on the northeast grid, so they're hard to see on the projector, but they should be visible on what you've written. You go over 1 and up 2. So 2, 1 sort of street, 2, 1 street. That's equal to 1, 2 northeast. You know, write that as north, south, east, west. I don't know how to write it. So we're going to go north, south, east, west. So 2 over, 1 up, same as 1 east, 2 north. What about the reverse question? Here I'm giving you the east and west coordinates, and I want you to give me the street coordinates. So now that you guys know the trick, this should be very fast. Okay, let's see if there's a consensus on this one. I guess the word cloud is the quickest way to check. A lot of people are saying 5-0. 5-0 is the correct answer. So 43% of people got that right. The way you look is you just look at 4-3, I guess is, let's get the stick again. Now it's over here. This is the best thing about this class is the stick. It's really nice today. 4-3. 4 east, 3 north. We're talking about this point up here. This point is also 5 blocks to the left, I guess, on the grid left of City Hall. Okay, very good. So we understood that. It's easy with the picture. Now you got to do it with linear algebra. That's the next question. How would you set these up with linear algebra? Of course, like I said, you can do basically any problem in this class with linear algebra. Some are harder and some are easier. Both questions, the first question and the second question, you can write as linear systems. One of them is a sort of really easy linear system. The other one is kind of tricky. And I'm asking you to set them up and tell me which one was easier and which one was harder. So remember, you're given a whole bunch of information in this problem, like the vectors for the 2 coordinates. You might have to go back a question and read what those are for this thing.
Not really. For 10 hours.
Okay, I think everybody's actually answered already, so maybe we can finish the question a few seconds early here. Any objections? Who's still going? Nobody? Okay, good. Let's see what people think. Some people think they're the same. I think if you think they're the same, you didn't do the problem. You were guessing. The two things look very different to me. Which is easier, which is harder? I guess people are split anyway. So one, let's think of the two directions. So you should have sort of two systems written down in front of you. What are the two systems? So one is converting street coordinates to east and west. One is converting east and west coordinates to street. They're both finding something. How would you write them as equations? Somebody who did it. Wrote them down as equations. Let's see, should I pick someone randomly? Do you have it? Would you like to share it? What you have?
I have no idea.
You have no idea. Okay, that's good. That's very honest. I appreciate that. Do you guys need more time?
No.
No? Yeah.
I think the first 3.71 would be some scalar times d1. Well, not some scalar, but the amount of blocks we move to the in one direction.
Yeah, here, let's open the question up so we can see. So in the first question we were doing 2-1. So 2, 1 means you go 2 units in the direction d1, and you go 1 unit in the direction d2.
And that's equal to some vector x, y. Or some point x, y.
Yeah, so it's equal to something, let's call this something x, so it's x east and y north. Okay, what about the other equation? Yeah.
The other one would be x times d1 plus y times d2 is equal to whatever point is given here.
So this one I think was 4 over and 3 up, is that right? So the first equation, you have 2 and 1 as the coefficients in front of d1, d2. You're trying to solve for x and y. In the second equation, you know the answer is going to work out to 4, 3, and you're trying to solve for the coefficients in front of d1, d2. So those are the 2 questions in terms of systems. I'm going to give you guys a chance to revote. So let's do another minute here. I don't know what happened last time. Alright, just a few seconds left here. What do you guys think? Let's see if the votes have changed at all. Oh, okay, a lot of people think the first one is easier. Why is the first one easier? If you write this one as a linear system, it says x equals something. That if you want to solve for x and the equation says x equals something, then you win. It's very easy to solve for x when the equation is x equals something. So in this case, I guess it's 2, this is 2 times 4 plus minus 3 times 1, all divided by 5. So x equals, you just add it up. You know what d1 and d2 are, you add them up, you get x and y. This one's very easy. This one is like an honest linear system. You got combinations of x and y, and you have to figure out what they mean. This one, you really have to solve some stuff. So 1 was sort of really easy, and in fact, I would say, you know, to misuse a word, I would say it's trivial, right? That means something in this course. Don't use that word. This one is sort of harder. You gotta unmix up the x's and the y's. All right, this is going to come up again later. That's why I wanted to bring it to your attention. Okay, last question. You can tell from the grid that the north and east direction, that spans the whole plane, right? These 2 vectors, which are called E1 and E2 in the question. So hopefully you read the question and know what those are. E1 is the east direction, E2 is the north direction. And the question is asking, do they have the same spin? This one should also be quick. Let's do just 1 minute. Okay, are they equal or not? 90% of people think they're equal. They are indeed equal. Well done, guys. So you're not totally dead today, just mostly dead. You get the easy ones, very good. What's the point of this question? If the span of them are equal, if the span of one set equals the span of another set, then that means the span means the set of all linear combinations. So that means that every linear combination of E1 and E2 is also a linear combination of D1 and D2. So if you have any linear combination of one, you can always rewrite it as a linear combination of the other. That's what we were doing here. We were doing it for some specific vectors. If you have it one way, you can rewrite it another way. If you have it this way, you can rewrite it another way. So these things, this is x east and y north. This is equal to x times d1 plus y times d2. Maybe that's what's writing down. 2d1 plus 1 d2 equals x d1 plus y d2. That was the first problem again. So this and this are the same thing. And the second one is saying x d1 plus y d2 equals 4d1 plus 3. So the fact that they have the same span is exactly what we were using before. You can always rewrite any point in either system as a different linear combination, and the question is, how do the coefficients change? So now that we know you can write everything as linear combinations of either, a really natural question is if you have a point, let's pretend there's a point y, that's the point in this question. You got 5d1 plus 5d2, that's equal to 1e1 plus 7e2. So 5, 5, street equals 1, 7, north, south, east, west. And the question is, what's a better way to think about it? Should I think about y as 5, 5, or should I think about it as 1, 7? Which one is better? Again, soft question about how you think about things, but those are the most important questions. So, I'm going to give you guys a minute. Feel free to discuss with your neighbors what's going on here.
Always on top of that. Oh yeah.
All right, let's see what people think. Is 5, 5 better or is 1, 7 better? The answer is, 15%, 26%, 21% they're equal, 38% think it depends. It's all over the place. It's all over the place. I think because this question is kind of, it's like it depends on how you're feeling. Maybe it's better to have a discussion about it rather than let you guys revote. It'll probably just flip-flop around when we revote. Anybody who thinks 5, 5 is better or 1, 7 is better? Maybe you can tell me why. And I'm open to discussions for either option. Yeah. Well, first of all, which team are you on?
1, 7.
You're on 1, 7. Why is 1, 7 better?
Because I really didn't see a way that I could ever get 5, 5. The only way you get 5, 5 is if it's 5d1 plus 5d2, and that's neither of the options. Like the linear combination 5d1 plus 5d2 still results in 1, 7, and e1 plus 7e2 still results in 1, 7.
Okay, so you're saying like 5, 5 is sort of a mirage. 5, 5 is an illusion, and like the truth is it's 1, 7. Because you got 1e1 plus 7, 7e2, that's 1, 7. And the d1s and the d2s, those are just some like whack-a-many vectors that somebody made up, and like that, 5, 5 isn't like a real thing. Is that?
No, there's no way you can get 5, 5 from d1 and d2, because that linear combination also evaluates to 1, 7.
Oh, I get it. Okay, so you're saying if you compute, if you take the d1 and the d2 as they were given to you, don't worry about where they came from. You just take the d1 and the d2 as they were given. You compute 5 times d1 plus 5 times d2. What comes out of that is 1, 7. So 1, 7 is the best thing, because that's what you get by using the things that were given. Great argument. Really nice. Anybody for the other side? So that was a 1, 7 is better argument. Anybody in 1, 5? I guess 15% of people were 5, 5. Not too many people. Yeah.
I mean, not officially 1.5 or 5.5, but for D, like
Yeah.
it depends. Just because, especially if the question's dealing, the question before was dealing with like city planning. So 5.5 might just be more accessible if your city's planned on the basis of a different coordinate grid.
5.5 is more accessible if your city is planned on a grid. If you're a tourist and you ask somebody, how do I get to Central Park? And they say, go so and so far north and go so and so far east. Here's a compass. They'll walk right into a wall. That's so good. You gotta tell them, what streets do you go on? So 5.5 is better for telling people in the city where to go, right? If you tell them go north and east, useless. You tell them go 5 blocks, then turn left, then go 5 blocks, that's a perfectly valid answer to the question. So 5.5 is better for city planning. So you're on team, it depends.
Yeah. It depends.
What situation do you think 1.7 is better?
If you're in the wilderness.
If you're in the wilderness, yeah, that's good. Or if you're in a plane or something, or if you're using Google Maps and you want to find something. That's because Google Maps is set up with you have a screen and the screen already has sides and the sides are aligned with north, south, east, west. If you're using, I don't know, a different Google Maps that was on the city grid, then the 5.5 one would be better. So that's the it depends. How do we reconcile what he's saying? Because what he said was totally right. If you put in the vectors, D1 and D2, and you compute what comes out, you get this box thing, and the numbers say 1.7. So it does seem like 1.7 is a little bit better than 5.5 in that sense. So is 1.7 a little better? And sometimes it depends? Or are they sort of equally good, and it just depends? Yeah?
I think you just always want to use the relative values whenever, in this case, the city relative.
So you're saying they're equally good?
Well, 1.7 could just get 2 walls here as well.
Uh-huh.
If you move 1 absolute into east, 7 absolute is north.
Yeah.
Who's to say not to go through it?
Right. So 1.7 definitely, in the context of moving around the city, is worse. But somehow, from the point of view of linear algebra, everything we've written here, it looks like 1.7 is better. Because when you do the boxes, right, in the boxes, it would say 1.7. If we were going to write y with box something, it would say 1.7. So it seems like, 1.7 is a little bit better because of that reasoning. So let me give you guys the answer. The answer is 1.7 seems like a better option because we decided at the beginning of the question that we would write everything in terms of east and north. So we decided, without saying anything, that every time we write boxes, we're going to write east and north. And because of that decision, everything seemed like east and north was better. It was easier to convert into east and north. It looks like east and north is the right thing. And it was all sort of an arbitrary decision we made right at the beginning of the problem. And actually, it's a decision we made at the beginning of the course. Every time we've written a vector, I've said things like, so here's an example. Let me erase these things. On the very first day of the course, we had the magic carpet and hoverboard, and I wrote a grid like this, and then I wrote a vector that went in some direction. The vector looked like what? It was some vector, it looked like this, and I said, this is the vector 3, 1. And I wrote down 3, 1. But I had already made a choice here. I was deciding that every time I write a vector as a box, I'm going to put in the number of places east or right in the first thing and the number north in the second thing. This was an arbitrary decision, and somebody else's linear algebra class, they could have made a totally different decision. They could have said, I'm going to call this 1 block left of City Hall, and so they could have equally well, they could have written. So it seems like north and east are better because we've been using it the whole time, but actually the only reason it's better is because we decided to use it for everything else. The next topic of this course is change of basis, and we're actually going to address this idea head on. We're going to say, from now on in the course, we're never going to write a box of numbers like this without being very clear about what we mean. So from now on in the course, when we write 3, 1, instead of just saying 3 over 1 up, we're going to say 3, 1, and we're going to say in the east-north basis. So that's what this definition is. It's a representation in terms of a basis. This one is pretty meaty. It's a bit of a mouthful. So take a second and read it for yourself first, and then I will give you guys some time to ask some questions about it. So this is definitely a harder one to grasp, but I think you guys can do it. So take a minute, read that carefully, and we'll go over some of it in a bit. Any questions or comments so far about the definition or what it is? This one is very subtle. So you gotta really be careful with this one. The subscript B can mean two different things depending on what is inside it. You gotta be careful, make sure you know what is what, where things are going. Who thinks the definition is okay? They think that they can figure out this definition the same as all the other ones. Who's totally confused by this definition? Okay, a few people. I guess most people are either asleep or halfway between. So let me just tell you what these two B's are. You should read it carefully here, and remember, part of the course is being able to read definitions you've never seen before. But those two different B's, they represent two sort of different operations. One of them is converting a vector into coefficients, and the other one is converting a coefficients into a vector. So if you have something like somebody draws an arrow on a plane, that's a vector, and one thing you can do is you can convert this vector into the coefficients 3, 1. So that's one of the directions. It's vectors, they get converted, into coefficients. How would you convert a vector into coefficients? Well, you need to choose a basis, and once you've chosen a basis, then there's only one way to convert a vector into a coefficient, to a list of coefficients, and that is by choosing the coefficients according to this formula, so that when you add up the coefficients times the basis vectors, you get the original vector you got. So this is converting vectors to coefficients using a basis. That's what we call, this whole operation is what we call V subscript B. Take the vector B, use the basis B, and convert it into coefficients. That's the first thing. The second thing is the reverse. That's when you start with coefficients, and you convert them into a vector. How would you convert coefficients into a vector? Well, you need to use a basis B. If you have a basis B, there's only one way to convert coefficients into a vector, which is to do the linear combination of the basis using the coefficients you were given. That's the second operation. That's A1 AN subscript B. This means convert the list of coefficients A1 to AN into a vector using the basis B. So those are the two different operations. It's confusing, or it can be confusing, because they both use a subscript b, and that's because in both of them, you have to use a basis in the middle, but the starting and ending points are opposites. One of them is converting coefficients into a vector, one is converting a vector into a list of coefficients, and we're going to always write lists of coefficients as column vectors, which is another reason it can be confusing. You got to keep track of what are we thinking of as a list of coefficients and what is a vector. Okay, that's my brief little explanation of this definition. Of course, you have to know the definition on its own. This is how I remember it. This is not enough information to understand what's going on. This is sort of the little icing on top to make it easier to understand. Okay, so with that, let's move into the first question here. Problem 38.1 is a question that looks familiar. Take a second and read 38.1. Try to apply the definitions. If you can get this one right, then there's a good indication you understand what's going on. So take a stab at 38.1. You've had a couple minutes to look at it. It should remind you a lot of the city planning question. So I'm going to ask the same question I asked for the city planning question. Which one is easier? You should be able to set them both up as linear systems quite easily. That shouldn't be something that's hard for you. But when you go to solve them, they sort of look different. So figure out which is the harder direction, which is the easier direction. All right, let's see, what do people think here? Big majority for 38.1, or maybe some people are scattered here, but 38.1. 38.1 is converting C1 and C2 into linear combinations of E1 and E2. So what would that mean? That means writing C1 equals something times E1 plus something times E2. So writing C1 as a linear combination of U1 and U2. You can give these names. Maybe you call the first something X and the second something Y. If C1 equals X times E1 plus Y times E2, then that's the same as XY in the E basis. XY in the E basis means convert X and Y into a vector by using the linear combination of vectors E1 and E2. So this and this are exactly the same. So the first question is asking, can you express C1 as something in the E basis? And the way it was given to us, it was 2-1 in the E basis. So C1 is 2-1 in the E basis. X E1 plus Y E2 is XY in the E basis. So it's very easy to read from this that 2 is going to be X and 1 is going to be Y. So that one is simpler. You can also set it up as a linear system and solve. The other one is more complicated. The other direction is saying that E1 equals X times C1 plus Y times C2. And so now if you want to think in terms of bases, you've got to think in terms of the C basis, and nothing in the problem was given in terms of the C basis. So there's always a bias in problems. What basis were you given the information in? In this one, you were given everything in the E basis, so this problem is harder. Next up, I'm just going to ask you, what is the answer? So write E1 and E2 in the C basis. So what I called vector V1 and V2 in the problem, I meant to write C1 and C2 in the original problem. Tell me what the coefficients are. This is going to involve some actual solving of systems. What are the coefficients?
Oh, we put them together.
Who needs more time? Lots of people. Okay, let's give you guys some more time. Okay, let's see how you guys did. I hope that you were able to at least get to these two linear systems. So if you take these equations and you write everything out in terms of their components in the E1 and E2 basis, in the E1 basis this looks like 1, 0, and this looks like A times 2, 1. So C1 is 2, 1 in the E basis, and C2 is 5, 3 in the E basis. So you should have at least gotten to here. If you didn't get to here, it probably means you're not understanding this basis definition, and you need to practice it. And once you have these two systems, they're like something you could give to a high school student, 2 equations and 2 unknowns each. You solve for the equation. Oh, I did something dumb though. I wrote AB twice, or I should have written C and D in this one. Let's fix that. C, D, D. Okay. Let's see how many people got it. Is there? So the biggest one on the block is 3 minus 1 minus 5, 2. I think that is correct. Let me double check. 3 minus 1 minus 5, 2 is the correct answer. So if you did that, very good. If you weren't able to do that, this is a very basic operation that you need to be able to do. The next part of the problem, there's a vector v, and you got to write it in both the E and the C basis. One of them is easy, one of them is hard. I'll leave for you guys to do that one at home. That's also involves solving some system. But what I want to talk about is the last two parts are going back to what we talked about at the beginning of class today, which is matrices. And we're looking for a matrix X that converts lists of numbers in the C basis to lists of numbers in the E basis. And the question is, how should we think about the matrix X? And you got options here. There's columns, rows, plugging in stuff, something else. Maybe you have no idea. So I'll open this up for a few minutes here and think about how should we think about X? We want X to convert the C basis to the E basis in some sense. So think about how you would set it up. What would that look like? Okay, 10 seconds left here. How should we think about the matrix X? Let's see the responses. 48% of people think we should think in terms of columns. Why columns? Anyone want to tell us what made you think of columns? So I wrote some of the hits here on the board. If W is AB in the C basis, that means W is this linear combination of C1 and C2 with the coefficients A. If we're thinking in terms of linear combination of A and B, when you write the matrix product X times AB, is that something like A times something plus B times something else? So we want this to be A times something, B times something else. Is that columns or rows? people are muttering, but I can't hear what. Did you guys say something here? Yeah.
It'll be columns.
This is columns. So when you do linear, if you want to do linear combinations using the coefficients of the thing you multiply by, the answer is columns. So thinking in terms of columns is a useful thing to do in this problem. Plugging in stuff will also work. This is a good practice problem. See if you can understand how this matrix thing works in terms of columns. The columns of the matrix X are really related to this problem. So when we get back on Thursday, we'll finish this one up. We'll figure out what the matrix X is. You should take a look at it in the meantime and see what it has to do with the columns. All right, thanks very much, guys. Enjoy your green home.